Welcome to this session. This session, we discuss the Lamis theorem and do an example on how to apply Lamis theorem. Lamis theorem says that if three forces acting at a point, as shown in this diagram, are in equilibrium, then the forces and the angles are related by this equation, that F1 over sine alpha, so F1 over sine of angle opposite equals to F2 sine over sine of opposite angle equals to F3 over sine of the opposite angle, gamma. So this is the statement. Here we have a problem. To solve for F1, F2, and theta, given that these three forces, F1, F2, and F3, are in equilibrium. So to solve this one, we apply Lamis theorem and say that since the three forces are in equilibrium, then F1 over sine, so the opposite of F1 is theta, should be F2 over sine of opposite angle is 102 equals to F3 over sine of 145. But you say angle at a point add up to 360 degrees. So 145 plus 102 plus theta should give us 360 degrees. And 145 plus 102 is 247 plus theta should give us 360. So which means theta alone, the 360 degrees minus 247 degrees, that will give us 100 and, so that is 145 plus 102, 247, so 360 minus 247, we get 113 degrees. So this angle is 113 degrees. So that when you say 113 plus 145 plus 102 gives us 360. Now, because F3 is known, so we'll have 150 over sine of 45 should give us F1 over sine of 113 degrees. So F1 will be 150 sine of 113 divided by sine of 45 degrees. So 150 sine of 113 divided by sine of 145 gives F1 will be 240.7276856 newtons. And then similarly, 150 over sine of 145 should give us F2 over sine of 102. So cross multiplying gives F2 to be 150 sine of 102 divided by sine of 145. So we'll have 150 sine 102 divide sine of 145. So that is 255. F2 is 255.80 2245 newtons. So that's what defines the value of those given values which are unknown in the problem. 150 divide sine of 155. So that's how we solve for F1, F2, and theta. Thank you.